Right, this is an introduction to the use of stereoanalyst in ArcGIS. This window, as you can see, is the basic ArcGIS opening window. It's got a couple of extra toolbars on it which are greyed out. They're actually stereoanalyst toolbars. This assumes that stereoanalyst has already been loaded on the computer and set up for use. First thing you have to check to see is whether the actual extension has been activated. The stereoanalyst extension needs a license file, which may be a floating license stored on another computer, or maybe a fixed node license on the computer that you're working. In this case, stereoanalyst is on. Next thing, click on the stereoanalyst drop down in the stereoanalyst toolbar. This can be located anywhere on the screen, but in this case it's down the bottom of the table of contents. Check on options. I like to orientate the ArcMAP display with the stereoanalyst display and make it follow the cursor and the window extent, just so that you know what it's looking like in both stereoanalyst as well as in ArcGIS. For your stereo display, I like to just show the overlap region, just accept the rest of the defaults, and advanced, show the north arrow, which is quite often useful. There's a range of other functions in here that you can control, but for the time being we'll just accept the default settings. Apply that. Now, the first thing that you'll need to do is to open the stereo window. It uses this icon down here on the stereoanalyst toolbar, and it creates this window in the centre of the screen and moves whatever was in the ArcGIS window to the side. And this area to the side, this white zone, is actually the ArcGIS window, which has been displaced by the stereo window. The next thing you'll have to do is to add your data. This is a blank document, and the first thing we should pull into it is the actual image information. The swathe information should be the first thing we pull in, because it sets the projection for the map document, and that seems to make it happier, and it doesn't have as many hiccups as when it's not the first item pulled in. The ADS40 datasets that have been received by the department have been reformatted to refer to a V drive, and you'll see on this screen that there is a V drive set up. If it's an external drive, you can map the network drive to V. If it's an internal drive, there are DOS commands that you can use to do that, but make sure that the topmost file in the folder is the topmost file in the dataset. To explain, if we open the V drive, you'll see that there are 6 different datasets under the V drive. Each one is preceded by a mission number, and at the end it has its resolution in the sampling distance. Now in this case we can pick any particular one of these. So let's have a look at the Montague Island dataset. So we open up the Montague Island dataset with a double click, and we wait. Right, underneath the top level folder there's a range of other folders. This folder arrangement varies from dataset to dataset. It has semi-standardized in recent times, and underneath the top level folder you'll find a similarly named folder without the mission number in front of it. If we open that one, you'll see inside this folder that there are a range of different files. There's only a few in this particular dataset because it's a fairly small one, but the ones that we're interested in are the subfiles. Now if we continue and we want to open up these support files, you'll see that there are level 1 and level 2 images in this folder. We're only interested in the level 1 for stereoscopic viewing, and in this case there's only 2 swathes of information because it's a very small area. So what we'll do is we'll highlight the level 1 support files. These are file named according to the area, which in this case is Montague Island. 10 centimeters resolution. There's a date and a time in UTC, red, green, blue, a backward and an AD swathe, and they're both number 1. So we'll add these to the map document. This takes a few moments to load. You can follow the progress of the import by looking down the bottom of the screen, and you'll see error messages down here on the lower left side. You'll see that the images have loaded into the table of contents, and the right hand side over in the ArcGIS window is the actual ArcGIS view of these images. Now I'll actually turn off the swathe information. Now I'm dealing with the ArcGIS table of contents, and you'll see that it's disappeared from the ArcGIS display over the right hand side. If I zoom to the full extent, you'll see that there on the screen is a couple of rectangles. You'll notice in the stereo window that north is to the left in this case, so the swathe information is shown in ArcGIS. The yellow box indicates the active swathe that we're looking at, and if I did the same thing again and open up the other swathe, the number 2 swathe, I'll explain to you how you select between them. Once again, it takes a few moments to load. As I said, you can follow the progress of the load down in the bottom part of the window. Because these are also quite large files and there's a fair bit of infrastructure formatting of the program to set up prior to pulling them in, it does take some time. So I'll just pause this while it's loading. Okay, that's been about 2 minutes, and it's loaded up the second swathe. You'll see that the second swathe is actually showing up in the ArcGIS window because I haven't turned it off. I'll do so right now. So that in ArcGIS all we have is the outlines, or what's called the stereoanalyst footprint layer. Shows you where each of the swathes lines up in space. You'll also notice that, I'll just resize this a little bit, there's an overlap at the end of each swathe where one swathe is captured, one sensor, the nadir or the backward sensor captures beyond the end of the run of the other sensor. Now to change between them, and to change the display in the stereoscopic window, stereo window, we use this icon, select image pair by ground point, so we can click on that, and then we can click within the swathe that we wish to view. You'll see how the yellow rubber band has jumped to the other swathe. If I click on that, it will change the swathe that is active and change the display in the stereo window. Okay, we now have a different swathe in the stereo window, and we're seeing a lovely red and green colour of the ocean. So if I select one of the zoom tools, I can actually depress the scroll wheel on the mouse and drag the mouse. It will do a continuous zoom out. Sometimes you have to wait for it to catch up. Okay, there's our stereoscopic view of Montague Island in the stereo window. We can zoom in on the selected area. And you'll see that that's an anaglyph image of the coastline on the western side of Montague Island. You'll also notice that if you're looking at it with anaglyph glasses, that the stereoscopic display is actually inverted. The ocean is higher than the land. To change that, we use this tool, and inverts the stereo model, and then puts it back into the real view of the world. It happens because one swathe has been flown in one direction, the other swathe has been flown in another. You'll also notice that the ArcGIS window has changed the zoom to match the stereoanalyst window. I have the toolbars arranged next to the windows. Generally, you can drag these over here. The way I like to set these up is so that the stereoanalyst toolbar is actually next to the stereo window, and the ArcGIS tools are next to the ArcGIS window. It makes it easier to find the tool that you need. I can use the hand tool to click and drag around in the stereo window, and use the zoom in tool to zoom in on a given area. Just take a few moments to rewrite that screen. There we go. And this is a 10 centimeter resolution image, so it's quite good and easy to make things out. Now you may find that the image is difficult to view because there isn't a very good stereo model, in other words an alignment between the two images. If that's the case, you can use this tool, a simple way to adjust it, and you'll see that in the bottom of the screen there are two small windows that are not in stereo. There is a crosshair in both of them, and the idea is to line up the crosshair in both of these bottom windows on the same point on the ground using the scroll wheels. The Z wheel varies the vertical coordinate, and that enables us to adjust the stereo model just like you would with a stereoscope. And you can see by moving that the crosshair moves over different areas in the image below, and like Murphy would have it, this is in a lousy position to get the alignment correct, so we'll move it a little bit. Okay, let's move it across here. And we'll try that again. Now, you'll see that as we move the scroll wheel up and down, one icon moves to the right and the other one moves vertically. And now they're lined up over practically the same spot on the ground. Our stereo model should be comfortable to view. We'll go back to a full screen view, and that's a very nice stereo model from my perspective anyway. Now we'll just add a layer to the map that will enable us to do some editing. Now we get a coordinate systems warning because the layer that I'm adding is in GDA 94, which is a different coordinate system to that of the imagery. The imagery itself is in a coordinate system which is called LSR anchored, which is a job-specific coordinate system set up during the creation of the data set, which essentially mimics WGS 84, which is only centimetres different from GDA anyway. You'll see in the coordinate systems here that it's called LSR anchored. Okay, now to edit in the stereo window we need to do a couple of things. Firstly, we can set terrain following mode, and I would suggest that you use the automatic toggle 3D floating cursor. There's a manual toggle which enables you to go in and out of the window, but it needs to use the F3 key to turn it on and off, and if you're anything like me, you're continually forgetting. So now you'll see that there's a cursor moving around in the window. If you're not viewing this with anaglyph glasses, you'll see two cursors, but if you are in anaglyph mode, it'll be a single yellowish cursor. So I'll assume that you have a set of anaglyph glasses on to view this. To create a polygon in this window, you need to use the ArcGIS editing tools, and either use the editor drop down and click start editing, or as I have here, I've set up a icon to do the same job. Again, you get a coordinate systems warning, you can just dismiss that. Right, we're now in the window, and you'll see as I move the cursor around, in the lower right hand corner of the stereoscopic window there's actually an icon that flashes red and green, and that's telling me when I have a good coordinate fix for the X, Y and Z coordinates on the digital elevation model, and when I do not. Obviously a red point that's in there, I'm not getting a good fix on the stereo model, but where it's green I am. I now select the pencil tool with which to draw a polygon, and I have it set to create a new feature in the data set that I wish to create the feature in. So we'll just see if we can, in fact, create a nice polygon around our houses. There we have an polygon, sorry. And you'll notice that it's actually wrapped to the ground surface. If I want to attach a polygon to that, I can select Auto Complete Polygon, the same as I would in ArcGIS, and I can start inside it and digitize a polygon outside to link up to it. Okay. Bear in mind that this tree down here is giving me a range of different fixes because of its different density and the fact that the DEM finds it difficult to cope with a rapid change in elevation. You'll also notice that in the bottom of the stereoscopic window there are coordinates which scroll with the cursor, including the X, Y and Z coordinate. The Z coordinate is the height. In this case it's 61 metres where I was. You'll see if you follow that it's 63, 64, 65 if we go up the hill, 70, and if we go right up to the top of the lighthouse it's 91. Through here it's about 71. 71 on the rocks, 64 down on the grass. Continuing with the digitising, we'll go back to create new feature, and we'll digitise a polygon from down here up over our rocks and back again. And you'll see how that is actually wrapping to the ground surface, and that's what the terrain following mode does for you. Remember never to use a 2D dataset in the 3D window. If you're unsure of how to set that up, contact me or refer to the Stereoanalyst User's Guide. Now, as I've explained, most of these commands are fairly straightforward. These commands work as they do in ArcGIS, so we can save those features that we've created and we can stop editing. If we wish to change the swathe that we're looking at, we can go to the tool that I mentioned before, which is this image pair by ground point image pair selection tool. Click on that. We can use our ArcGIS zoom tool to zoom the window until we can select select that tool again, the swathe that we want, which is the southern, the western one, because north is to the left, remember. And when that's selected, the image inside the stereo window will change, as it just has. It's still in the process of realigning. And now we're looking at the new swathe. Another way to be able to see the entire swathe is to select the scale tool from the stereo window, which in typical with Murphy's law is going to decide to give me pain. Hang on, right icon will help. And we select say 1 to 250,000 scale, and there's our island right in the middle of the screen. Let's zoom in, shall we? Okay, and we'll zoom in again on the similar area to where we were before. And in this swathe you'll see that the boat that was heading out to sea in the first swathe that we looked at is actually still moored. You'll see it here. You'll also notice that now we've changed swathes and the direction of flying, the stereo model is now inverted. So we'll use the tool that we used before to re-invert it to the correct orientation. Let's zoom in a little bit more. And you'll notice that more so in using a planar unit, but even in anaglyph mode, you can actually make out some details of the subsurface terrain in 3D. We'll go for a bit of a look around, and you'll see that despite the fact that this is a 10 centimetre data set, it's actually possible to see mooring lines which stand out quite clearly. Now, that stereo model is not correctly adjusted. Another way that you can adjust it, in addition to using the two windows that I showed you before, is to focus on an area of the ground surface. In this case it's decided it's going to snap back into focus, which is great. But I was going to say that if you focus on an area of ground surface and look at the ground, you'll see a mirrored cursor. You could still use the Z wheel to arrange that stereo model by continually focusing on the ground, moving the Z wheel and bringing that crosshair together. You'll see that the resolution in these 10 centimetre images is quite good. And this is the same area that we were looking at before. Because this is a small data set, the imagery does cover the same area. There's a large overlap between the two swathes. You'll see that the polygons we created before are in the same positions in space, and they are still wrapped to the ground surface. Now, very briefly, to finalise this session, there are other controls that you can use in StereoAnalyst to improve the quality of the image. Down the bottom of the screen we have a brightness and contrast control, which you can use to improve clarity if necessary. You can adjust both the swathes, or one or the other. If one swathe is a bit darker than the other, you can adjust it independently from the other. And that's just about the end of a brief introduction into the use of StereoAnalyst in ArcGIS. Remember to save frequently. Just briefly, this is an introduction into StereoAnalyst for ArcGIS. Principally the importing of new ADS-40 stereo viewable information into ArcGIS. There's two main ways to do it. One way is to use the import project tool, which is in the StereoAnalyst toolbar, and the other way is to pull these subfiles in directly, which was explained in the introductory video. To use the import project tool, you need to select the project file. If we look at here, I have a number of different datasets in the V drive. If I select the Coffs Harbour file, the project folder, there's the block file, which is the photogrammetry project we have to pull in. Now it's gone off looking for the information, and it's come back with there are 7 images in the project. I'm actually copying files to this folder as we speak, so it's found 7, it'll find the rest of them soon. If I go to the next view, you can see that it's highlighted all the different swathes in the dataset that it's found in the structure. If we go across to the right hand side, you'll see that there's still a few datasets that are incomplete. So there's 6 swathes of information that are fully complete, and there's 6 swathes that are missing partial orientation information. If we go back to the previous screen, you'll see now that there are 10 images in the project, so it's found some in the time that we've been speaking. Okay, let's go back to the start here, and we'll disable many of the ones that are not orientated. we now have two complete swathes, each comprising a nadir and a backward image, loaded, ready to go. The projection information is listed, the vertical coordinate system is listed, and it's now ready to import these 4 images into the map. As mentioned in the introductory dialogue to using a stereoanalyst, all the datasets that have been received by the Spatial Products Unit have been converted to a V drive to standardise, so that it makes it easier for end users to set the projects up. Stereoanalyst is finalising the import. You'll see down here that the messages are coming through as the project's pulled in. And there we have it. We zoom to full extent, you'll see that the ArcGIS window will show the stereoanalyst footprint layer and the projects that are pulled in. There seems to be an issue here. This swathe is not lining up properly, so there may be an error in the dataset. If I turn off 2 of the swathes, you'll see that the imagery for the remaining 2, which should be here, is actually shown in the wrong place, so there's obviously an error in the dataset. If we go back to our Import Project tool and we reselect our COFS project, and say for example some of the images are actually on another drive or somewhere else, or you've received a raw dataset which hasn't been repathed to the V drive, you can tell stereoanalysts where to find the data by using this tool. Okay, we'll go through. Now, you remember that when we had a look at this the first time, we saw that there were some swathes that were completely and fully orientated and some that weren't. Now, if we wanted to find the internal orientation information for this swathe, we can double click on that square and it will give us the information that it's searching for, the level 1 ADS image, and the path it's searching for is viewable by expanding this out. So it should be in the level 1 RGB images folder, but it's obviously not there. If you know where it is, you can double click on this and you can tell the system where it is, and so you can set it up manually. And you'll recall that in the introduction to Stereoanalyst we mentioned that without using the import project dialog, you can actually pull information simply into the map document. So this is a blank map document. We use the add data tool. We go to the same folder. Here's our top level folder, Cost Harbor. Open that, open the project folder, and you'll see in the project folder there are these support files. And the ones that we pulled in before were 4 and 5. So if we highlight those, we can add them this way. The block file goes looking for these files to actually import them into the dataset. This way you go looking for the support files to pull them into the ArcGIS window. So that's now working. As it says here, it's updating the footprints, constructing the image pairs. Image pairs are now loaded, which you can see in the toolbar, and the ArcGIS window is now finishing loading them. So the same situation as we had before using the block file. So that's basically how you pull stereoscopic image information into Stereoanalyst for ArcGIS.